Alright, so this is question number 11 of homework 5. So let me read the setup first. Linda loves buying shoes and going out to dance. Her utility function for pairs of shoes S and the number of times she goes dancing per month T is U S T equals 2 times S times T, with marginal utilities. Marginal utility of S equals to 2 times T, and marginal utility of T equals 2 times S. It costs Linda $25 to buy a new pair of shoes or to spend an evening out dancing. Assume that she has $400 to spend on shoes and dancing. And number 1, use the line drawing tool to draw Linda's budget line. Label this line budget. Number 2, use the point drawing tool to locate Linda's optimal consumption bundle. Label this point R. And so this is a typical question of solving for the optimal consumption bundle of a consumer given the budget constraint and prices of the goods, and as well as the income and the utility function. For the first part, it should be relatively straightforward. So use the line drawing tool to draw Linda's budget line. Label this line budget. So if we look at the setup, she has $400. That's her income. And the price of shoes is $25, and also the price of spending an evening out dancing is also $25. So the budget line, let me put this on the OneNote. So the budget line basically is price of it's going back to the shoe, right? It's price of shoes times the number of shoes S plus price of, let's say, dancing times the number of dances she goes dancing. That should equal to her income, which is 400, right? So this is basically the budget line, and the price is given, that's 25S plus 25D equals 400. So you can actually further write down this as a 25 times S plus D, right? Because both of these has 25 here, so you can combine the terms, and that equals 400. So and then you can solve out this as the S plus D equals 400 divided by 25, that will give us 16. So S plus D equals to 16. That's the budget line. So and then going back to the problem, so if S plus D equals to 16, then on both the vertical axis and horizontal axis, the intersection is both 16. So now we can draw that line. First point on the vertical axis, 16. Second point on the horizontal axis, also 16. and this is the budget 9. Budget. So before we go further, let me just check my answer. Oh, we haven't done that yet. Sorry, I guess I can't do that. I have to finish both parts, and that's the reason I believe why it's showing the incorrect line. So number 2, use the point drawing tool to locate index optimal consumption bundle. And so far we just located the budget 9, and we know that the optimal consumption bundle must be on this 9, but which specific point we don't know yet. But we can solve that out. How do we do that? Going back, that has to go back to the section 4.4 of chapter 4, which is about the constrained consumer choice. So if you look at equation 4.6, that we have what we have there is basically marginal utility of S divided by marginal utility of D equals price of S divided by price of D, because price of both S and D is 25, so that equals to 1. And marginal utility of S, if we go back to the setup, that's 2 times T, and the marginal utility of T, that's 2 times S. So now we have 2 times T over 2 times S, that equals to 1. And now that will give me basically 2 cancels out, so T over S equals to 1, and that further gave me T equals to S. So that means for the optimal consumption bundle, the number of pairs of shoes must be equal to the number of times Linda goes dancing. And then don't forget about the budget 9. So we have one equation here, and we need another equation to solve out these 2 unknowns. The other equation is right here, S equal S plus D. S plus D, and this is another one. So if you plug this into that budget 9, what you will get? You basically will have a 2T, right? Because T equals to S. So if you plug that into I guess maybe I used the wrong. I should have used T, but instead I used D. But that's just a typo. What I should have here is a. So let me just correct that typo here. So this should be T. So T equals to S. So 2T equals to 16. Hence, T equals to 8. And hence, S also equals to 8. So both equals to 8. That's our optimal consumption bundle. So now we can pinpoint this point, which is right here, for both pair of shoes and number of times going dancing equals to 8. So that's our optimal. It's a bit sometimes this may not be very precise, but what I found from Pearson my econ lab is that even though your point is not exact, you can still get a point. So let me try this. I know that the optimal bundle is 8 by 8, but what I have here is 8.05 by 8. So let me just check whether my answer is right. That's just yeah, excellent. You can see that you can still have some tolerance level for the point. It doesn't have to be exactly on the spot. As long as it's close, your answer will still be marked as correct. And the second part, what is Linda's marginal rate of substitution? We know that the marginal rate of substitution equals, and that should if refer to the marginal rate of substitution between shoes and Johnson at the optimal consumption bundle. So at that point, we know that based on the equation 4.6 on chapter 4, marginal rate of substitution equal to marginal rate of transformation. And marginal rate of transformation further, so let me write down this, marginal rate of substitution equals marginal rate of transformation, and that further equals to negative the price of a good on the basically on the horizontal axis, and in this case that's the shoes, so that's the PS divided by the PT Johnson, and because both goods have the same price, so this equals to -1. Okay, so the answer here is -1. Already has the negative sign, so we just need to input 1. So finally, check the answer. Excellent. Good. So this just by using this example, I just want to show you how to solve out the optimal consumption bundle given the prices, the budget, the income, as well as the utility function, and also how to point that on the graph.